Welcome to my kcse revision channel, Teacher James Marita, Grigorius Boys High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at a kcse revision, question number 23, kcse last year 2023, and that is the question on the differentiation, application of differentiation. So the displacement x meters of a particle moving along a straight line after t seconds is given by x is equivalent to t raised to power 3 or t cubed over 3 minus 3 squared plus 9. So A part 1, determine the value of t when the particle is momentarily at rest. Then Roman 2, you're supposed to find the values of the displacement x meters by the time the particles comes to rest. Part P, determine the values of t when the velocity of the particle is equivalent to -5. And then finally, determine the acceleration of the particles at t is equivalent to 2. What you are supposed to understand about this question is that you should have the concept of differentiation. The concept of differentiation here is very, very important. And what is happening at rest? What is happening at the highest point, the maximum point, the point at rest? So you should understand that one for one to score this question very well. So we are supposed to have this to find the values of t when the particle is momentarily at rest. You are to understand this momentarily at rest. This one here, you should understand that at the point of rest or the point of maximum or the point of minimum, the velocity, the velocity in that case is equivalent to 0, or what we call the gradient function. The gradient function of the particle at rest is equivalent to 0. That means that if the gradient function here, which is given by change in x here in that case, change in x all over, change in t in that case, that one should be equivalent to 0. So how can you differentiate this one here? So the gradient function in that case now you will have as 3, then we have t raised to power 2, then you divide it by 3. You take 3 times the coefficient of t, which is 1, then you reduce the power by 1. Then now we divide it by 3 minus, so we have 2 times 3, we have as 6, then we reduce the power by 1, and then we remain by t raised to power 1. So we have that t raised to power 1, it remains like that. And you understand that the derivative of any constant is equivalent to 0. It means now the derivative of this constant 9 is equivalent to 0, therefore we cannot be able to include 9 here because their derivative is normally equivalent to 0. The whole of this one here should give us at the point of rest or the point of maximum, the gradient function is equivalent to 0. It means that dy, dx, dt is equivalent to 0. So if dx dt, which is this gradient function, is equivalent to 0, it means that the whole of this expression here is equivalent to 0. So we can have 3 and 3. So we have t squared minus 6t. This one is equivalent to 0. T is common here, so we can have t outside. Then we have t minus 6. This one is equivalent to 0. Either we can say that t is equivalent to 0 seconds in that case. So we have t is equivalent to 0 seconds. That's when we say that it is equivalent to 0 seconds. Or 6 minus t, or 6 minus 6 minus t is equals to 0. From that case, you realize that negative t is equals to negative 6 divided by negative 1 and negative 1. The value of t is equivalent to the 6 seconds in that case. So at the point of rest, the value of t when the particle is momentarily at rest, you get that t is equals to 0 seconds and t is equals to 6 seconds. The values of the displacement, the values of our displacement x meters by the time when the particle comes to rest. So the values of x here when the particle comes to rest, we understand that x is the same as t raised to power 3 all over 3 minus 3t squared, in this case plus 9. So at rest we have two values of x where we have that t is equals to 0 or t in this case is equivalent to the 6 seconds. When t is equals to 0, at t is equals to 0, we will have x is equivalent to 0 all over 3, and in this case, this one is cubed, minus 3 times, in this case 3, 0 squared, so we have this is 0, and then we square, then plus 9. So the x, when it is equivalent to 0, this one will give us, in this case, 9 meters, because it is a displacement. So that one is, we have to indicate that one as the distance. Then at t is equals to 6, so we have t is equivalent to 6. What can we have? So we can have the values of x is equals to p 1 all over 3, and this one is cubed minus 3, and then we have this is 6 over that, and then we have t, the value of t is 6, so we have t 6, and then it's squared, and then plus 9. And if you simplify that one, it will give you 27 meters. So the value of the displacement x meters by the time the particle comes to rest is at t is equals to 0, the displacement is equals to 9 meters. At t is equals to 6 seconds, the displacement is equivalent to negative 27 meters. And when it is a negative, it means that the particle is normally falling down. The particle is falling down when we have a negative displacement. Then part P, we are supposed to determine the values of t when the velocity of the particle is equivalent to negative 5. Remember, this is our displacement. Once we differentiate displacement, we normally have the velocity. So from displacement, we differentiate displacement, and then we will have the velocity. So our velocity in that case, our v, which is velocity, is equivalent to t squared, in this case minus 6t. But we have been told that this velocity here, but we know that we have been told that the velocity in that case is equivalent to negative 5. Therefore, it means that we have t squared, then minus 6t is equals to t minus 5. We can format this automatically in a quadratic equation, where we can have t squared minus 6t, then plus 5. So we are transferring that 5 from the other side to this side, and then when we remove negative 5 from there, we remain there with 0. And this one now becomes our quadratic formula, whereby you can use various methods of finding the value of t. You can use the quadratic formula, or you can use a complete square method, or you can use the sum and the product, the sum and the product method. So if you can use the sum and the product method, you get that the coefficient of this squared here is 1. So we take 1 times 5. Our product is equivalent to p. Our product is equivalent to 5. And the sum in this that case, our sum is equivalent to negative 6. Then what are the factors? Factors are the numbers which we find a product, we can get 5. The same factors, the same numbers. when we find their sum, we are getting them negative 6. And these factors now, the numbers here, you can have, it is negative 5, of course negative 5t, and then we can have t, such that negative t times negative 5, negative t minus plus negative 5, we can have negative 6, and then we have our product. Of course, we have this one as 5t, this as 5t squared. Then we have negative 5t times t negative, negative and the negative is a positive, and therefore we have that one as 5t squared. So these are the factors. So we have that one as our factors. We have t squared. Instead of now writing negative 6t, we replace by this factor. We replace by sum of negative 5t minus t. So we can have this one as negative 5t, in this case minus t. This one will give us negative 6, and then of course plus 5, and therefore we put that one is equivalent to O. So we can group this one into 2, we group into that into 2, such that now here we have t is common, we can factor it out. So we have t, then we have t, this case minus 5, we subtract, and of course we have, this is now t minus 5, then we have 1 as the common factor. So, and then we can have this one is equivalent to 0. Then we have not this squared, we can have now t minus 1, so we have t minus 1 to that, to factor 2, this is t minus 5, and then this one is equivalent to O. So from here we can say that either, so we have either t minus 1 is equals to 0, and then from here we can conclude that the value of t is equivalent to 1 second. So the value of t from here is equivalent to be 1 second. Or we can also say that t minus 5 is equals to 0. So from there we can also conclude that the value of t is equivalent to 5 seconds. So we have the value of t from here is equivalent to be 5, is equivalent to be 5 seconds. So the values of t, when the velocity of the particle is negative 5, we can conclude that t is equals to be 1 second, or t is equals to be, in this case, 5 seconds. Then finally we have determine the acceleration of the particle at t is equals to 2 seconds. So before we substitute the value of t, we are supposed to understand how to get the acceleration. We differentiate displacement to get the velocity. From differentiation of the velocity, we can get the acceleration. And our velocity here was, our v is equals to p, it is a t squared, then minus 6t. This is our velocity. To get the acceleration from here, that is our a, it is a derivative of this velocity. So it means that we have a derivative of d respect to, we have derivative of dv with respect to t. So if we differentiate that one, we have 2 times 1, so we can have this one as 2, and then we reduce this power by 1, so we have 2 raised to t raised to power 1. Then minus, we have this one as, this is 1 here. 1 times 6 is giving us 6. Then we have, if we reduce 1 from here, we remain with 0. And any number raised to 0 is normally equivalent to 1. So any number raised to 0 is equivalent to 1. So t raised to 0 is 1. 1 times 6 is equivalent to 6. And therefore our acceleration is, from that expression of velocity, is equivalent to 2t minus 6. But what do we know? We know that the value of t in that case is equivalent to 2. So where there is t, we replace by 2, such that we have our acceleration now is equivalent to p2, in this case times 2, because t is equivalent to 2, and then we subtract 6. 2 times 2 is equivalent to 4 minus 6, and the 4 minus 6 normally gives us, in this case, negative 2 meters per second square. And that is the acceleration of that particle at t is equivalent to 2 seconds. Don't forget to subscribe my channel, watch and share. Thank you.